Our era is witnessing a rapid development in the field of millimeter wave and Internet of Things IoT technologies, with a projected 40 billion IoT devices to be installed by 2025. The integration of 5G technology in power systems is revolutionizing grid management by providing rapid, low-latency communication essential for real-time data exchange among smart meters, sensors, and control centers. This connectivity enables utilities to monitor and respond to grid changes instantaneously, which is crucial for integrating renewable energy sources, managing dynamic loads, and quickly detecting and addressing faults. As power networks become increasingly complex with the addition of distributed energy resources and Internet of Things IoT devices, 5G's high-speed data channels facilitate automation and more efficient energy distribution, ultimately leading to a more resilient and sustainable power infrastructure. Moreover, the improved reliability and scalability of 5G pave the way for innovative solutions and smarter operational strategies, ensuring that future energy systems can meet the growing demands of modern societies. What is 5G? The fifth generation of mobile networking technology. 5G works on the same principles as 4G. However, the new 5G and our new radio air interface will have wider functionality than just mobile internet, providing a higher level of scalability and flexibility. Broadly speaking, 5G can be defined in two ways. The first and more obvious is that 5G is the next generation of cellular technology following after 4G, with improved speed, lower latency, and the ability to connect more devices at once. For G2 5G, as the energy infrastructure of smart cities, smart grid upgrades traditional power grid systems with state-of-the-art information and communication technologies. In particular, as the full deployment of the Internet of Things in the power grid, the newly introduced information flow together with inherent energy flow makes it more efficient for power generation, transmission, distribution, and consumption. 5G is the fifth generation of mobile communication technology that promises to deliver blazing fast speeds, low latency, high reliability, and massive connectivity for various applications and devices. 5G can have a significant impact on the energy sector, which is undergoing a transition towards more renewable, distributed and smart power generation and consumption. Next generation of wireless technology can transform the energy sector. Some of the benefits of 5G for the energy sector are improved efficiency. 5G can enable faster and more accurate data collection, analysis, and control of power grids, reducing operational costs and losses. 5G can also support demand response and load balancing, optimizing energy usage and supply. Enhanced safety. 5G can reduce the exposure of workers to hazardous environments and high-voltage equipment by enabling remote monitoring and maintenance using drones, robots, and sensors. 5G can also improve fault detection and prevention, ensuring a stable and secure power supply. Higher reliability. 5G can provide real-time communication and coordination among various power grid components, such as generators, substations, transformers, and meters. 5G can also support mission-critical applications such as protection relays and circuit breakers, which require low latency and high reliability services. Better sustainability. 5G can support the integration of renewable energy sources in smart grid applications, such as microgrids, virtual power plants, and smart meters. 5G can also enable electric vehicle charging and vehicle-to-grid services, reducing greenhouse gas emissions and enhancing energy efficiency. Application scenarios for 5G-based precision load control services. Precise load control application scenarios. Precise load control technology refers to the precise control of massive distributed power users' interruptible load according to DC power loss in the context of DC blocking, large active power shortages and sharp frequency drops in the receiving end grid due to successive phase change failures and faults in multi- and feed DC power grid. This enables good interaction between the grid and power sources loads as well as instantaneous balance of power supply and demand, supports optimal energy distribution on a large scale, avoids mass power outages, and minimizes grid losses and the impact on business and residential electricity consumption. Differential protection for distribution network. Challenges of 5G for the energy sector are high investment. 5G requires significant capital expenditure to deploy and maintain, which may not be affordable or feasible for some energy utilities. 5G also requires spectrum allocation, infrastructure sharing, and network slicing arrangements among different stakeholders. Technical complexity. 5G involves sophisticated technologies that require high-level skills and expertise to operate and manage, which may not be readily available or accessible for some energy utilities. 5G also poses cybersecurity risks that need to be addressed. Regulatory uncertainty. 5G may face regulatory barriers or uncertainties regarding data privacy, cybersecurity, interoperability, and standardization, which may hinder its adoption or innovation. 5G also needs to comply with existing regulations for electromagnetic radiation exposure and environmental protection. 5G-enabled industry digitalization revenues will be $1.3 trillion in 2026. Examples of using 5G in the energy sector are the Sogno Initiative. This is a project led by Ericsson and involving 13 partners, including utility companies, to explore how 5G can enable virtualization and automation of power grid services. The project uses 5G to provide real-time communication and coordination among various power grid components such as generators, substations, transformers, and meters. The project also supports mission-critical applications such as protection relays and circuit breakers, which require low latency and high reliability services. The wireless power substation. This is a concept proposed by Huawei to use wireless technologies such as 5G, LTE, and Wi-Fi to connect various devices and systems in substations, such as protection relays, circuit breakers, transformers, and meters. Wireless connectivity can provide large bandwidth, wide coverage, low latency, and high security for data transmission and control. This can enable remote monitoring and control, smart metering, asset management, and cybersecurity for substations. The smart grid management. This is an application that uses 5G to support the integration of renewable energy sources and smart grid applications, such as microgrids, virtual power plants, and smart meters. 5G can also enable electric vehicle charging and vehicle-to-grid services, reducing greenhouse gas emissions and enhancing energy efficiency. 5G can also support demand response and load balancing, optimizing energy usage and supply. In-house deployment of smart meters. Some top uses of 5G in the energy sector are development of smart grids. 5G can enable faster and more accurate data collection, analysis, and control of power grids, reducing operational costs and losses. 5G can also support demand response and load balancing, optimizing energy usage and supply. 5G can also support the integration of renewable energy sources and smart grid applications, such as microgrids, virtual power plants, and smart meters. Deployment of smart meters. 5G can enable the use of smart meters to monitor energy usage and provide real-time feedback to consumers and utilities. Smart meters can also enable dynamic pricing, peak shaving, and energy efficiency measures. 5G can also enable wireless connectivity and interoperability among different types of smart meters. Remote monitoring of energy sites. 5G can enable remote monitoring and maintenance of energy sites using drones, robots, and sensors. 5G can provide real-time communication and coordination among various devices and systems, such as generators, substations, transformers, and meters. 5G can also improve fault detection and prevention, ensuring a stable and secure power supply. Energy efficiency and climate change mitigation. 5G can enable energy efficiency and climate change mitigation by reducing greenhouse gas emissions and enhancing energy efficiency. 5G can enable electric vehicle charging and vehicle-to-grid services, reducing fossil fuel consumption and emissions. 5G can also enable smart buildings and cities, reducing energy demand and waste. Internal processes improvement. 5G can improve internal processes within energy organizations by enabling faster and more reliable data transmission and control. 5G can also support digital tools for project management, sales, procurement, and other purposes. 5G can also enhance cybersecurity and data privacy for energy data. 5G is a revolutionary technology that can transform the energy sector by enabling faster, more reliable, and more sustainable power generation and consumption. 5G can support various applications and use cases in the energy sector, such as smart grids, smart meters, remote monitoring, energy efficiency, and internal processes improvement. 5G can also help reduce greenhouse gas emissions and enhance energy efficiency, contributing to climate change mitigation. However, 5G also faces some challenges and barriers, such as high investment, technical complexity, and regulatory uncertainty. Therefore, it is important to foster collaboration and innovation among different stakeholders in the energy sector to overcome these challenges and realize the full potential of 5G.